And now, after understanding all this, we are in a position to discuss these some wonderful phenomena which we have always assumed what may be the reason behind them to be so. Like the first, the basic of all those phenomena is scattering of light. So first let me tell you what is scattering of light. The scattering of light is when the light passes through the gas. When the light is passing through the gas particles, it may be the atmospheric particles, the gas particle, they absorb this light. And after the absorption of light, then they re-emit this light. So this absorption and re-emission of the light by the gas particle is called scattering of light. So once again I repeat, the gas particle, they absorb the light and then they are going to re-emit the light, and that's how it is scattering of light. And about scattering of light, there is important law, and that is Rayleigh's law of scattering. So this Rayleigh's law of scattering says the amount of scattering or the intensity of light scattered is inversely proportional to lambda to the power 4. It means that the amount of scattering of light or intensity of scattering of light depend on the wavelength. It means if I ask, we know the wavelength of red color is highest and the wavelength of violet color is the minimum. So if I say the which color out of violet and red will scatter the most by the gas particle, so our answer is just reverse. It means which color has least scattering out of this Vibgyor? Answer is red. Which color has the maximum scattering out of this Vibgyor? So violet, and all other colors would fall in between. And this is the important point which will help us in understanding so many phenomena which till now we were finding it hard to understand why so. So let's take all those phenomena one by one, and I would first take blue color of the sky. Just imagine why you have the color of the sky as blue. Can the color of the sky be violet? Can the color of the sky be red? Can this color of the sky be orange? And can some other planets have this different color of the sky? And why do we have at our planet the color of the sky as blue? You must have observed this blue color of the sky. So the answer is, in fact, if we talk about Earth, the Earth is full of thick atmosphere above it. It's all over a huge and thick atmosphere that lies above the surface of the Earth. So when this white light, it falls from the sun, which has got all the 7 colors as its component, as well as infrared, ultraviolet rays, and all different wavelengths, microwaves. But out of those 7 colors, the first color which will deviate the most, which will scatter the most, is obviously going to be the violet color. So in the first part of the atmosphere, it is obviously the violet color, it scatters the most. And then which color comes? Indigo. So the second part of the atmosphere, of the topmost part of the atmosphere, it must be the indigo color which gets scatters. And the part of the atmosphere which we see as the sky, it has mostly third color, and that is blue color scattered all over in plenty. So the part of the atmosphere which we observe as sky, it has got maximum scattering taking place of blue color. All other colors, violet and indigo, they are almost exhausted at the layers above. And that's why we see the color of the sky as blue. If the atmosphere of the earth was little more denser, we would have got the next color in the sky, and that is after blue, it comes green. We would have a green color of the sky. If it was more denser, we would have a yellow color of the sky. And if a planet or maybe Earth ever, it has its atmospheric density little less, we may have an indigo color of the sky, and if further less, we may have a violet color of the sky. So a planet which has atmosphere rarer than Earth is expected to have a violet color of the sky or indigo color of the sky. And a planet where the atmosphere is denser than Earth, you may have green color of the sky, you may have yellow color of the sky, and even you may have orange color of the sky. So it is just depending on the thickness of the atmosphere. For our Mother Earth, the atmosphere is such that it is the blue color of the sky which we see mostly scattered in the part of atmosphere which we look at as sky. Then now you can very well understand sun appears reddish at sunset or sunrise. So at the time of sunset or at the time of sunrise, why even the whole atmosphere, even the whole sky appears reddish. The sky would appear orange or some other colors, like you can see orange, yellow, but the sun will appear reddish. Now why it take place? Because now you can understand it well that there is a thick layer of atmosphere above Earth. So there is a thick layer of atmosphere above Earth. Now just imagine that sun is the farthest at the time of sunset or sunrise, and the light beam which is traveling from sun is suffering refraction again and again from different layers of the atmosphere. So it suffers first refraction, then it suffers like this, and then it travels, and this is how it travels. So this sunlight, irrespective if it was at the top during the daytime, the sunlight comes straight. It travels less thinner atmosphere to reach to you. But at the time of sunset or sunrise, the sun rays which are reaching to you are traveling through very thick part of the atmosphere, and they have been constantly refracted through different layers. So what happened that different colors, scattering of all those colors take place one by one till the time it reaches to you of the sun rays which are received by you. So it may be the sun ray which is received by you had first lost its violet color, then scattering of indigo color, then scattering of blue color, then scattering of green color, then orange color, then after it may be the red color which is finally reaching to you, because the scattering of red color is the least. So finally the light which reaches to you, it just consists of red color, whereas the colors which have just scattered are orange or yellow and then green color, like that. So what you observe is, you observe the sky as orange or yellow or maybe partly green, but you observe sun as red, because the sunlight which is reaching to your eye ultimately, which has scattered the least and is reaching in most part of the spectrum to your eye, is red color. So you see sun as red. So sun appears reddish at sunset and sunrise, where the sky appears colored. The reason is clear to you. Now the next important point which we discuss is why the danger signals are red in color. Now you can clearly explain them. Why the signals are made red, danger signals are made red. Reason is simple, that red colors has least scattering. So it is the red color which can reach the farthest without scattering. So that's why I would prefer to make danger signal as red so that they can be seen from farthest. Similarly, why the clouds are generally white, where the sky is blue, but the clouds are white. Why the clouds are white? So answer is that the clouds are made up of water particles and dust particles. The cloud consists of dust and water droplets. And these dust particles and water droplets, they do not follow Rayleigh's law of scattering. That is only for gas particles that the light is absorbed and then re-emitted. But it is not so for dust particles and water particles. Dust particles and water particles scatters all the colors equally. And that's why the clouds appear white. Similarly, sky of the moon is always black. Reason you can understand. The moon has no atmosphere, so there is no scattering. So sky would appear black. So these are the important points. So now we talk about another spectacular phenomena which you all have observed since your childhood, that is rainbow. Now just try to recall when rainbow take place. Is it during the daylight when there is no raining, or it is when there is raining and there is no light, no sunlight, or it is when there is raining and as well as there is sunlight? So your answer should be clear. It is during the time when it is raining and there is also sunlight. So the condition is clear. There should be raining, or it has just completed and somewhere nearby it is raining, and also there should be sunlight. These two things together, you will find rainbow. And when we talk of rainbow, there are always two rainbows. One is quite prominent, which is the primary rainbow. One is quite prominent, which is the primary rainbow. And second is relatively, relatively less prominent. Sometime it is visible, sometime it may not be visible, which is secondary rainbow. So the rainbows, you'll find two, primary rainbow and secondary rainbow. The primary rainbow is at an angle of elevation 41 degree to 43 degree. I'll come back to this. And secondary rainbow, it is at an angle of elevation 51 degree to 54 degree. It has got slightly more angular width. The color pattern in the primary rainbow is violet to red. So in primary rainbow, the upper color would be red and the lowest color will be violet. But in secondary rainbow, the color pattern would be just reverse. It is from red to violet. So primary rainbow has got color pattern violet to red, and secondary rainbow has color pattern red to violet. Secondary rainbow is slightly above and relatively dim. Sometime observed, sometime may not be observed. But primary rainbow is quite prominent, can be observed easily. You all must have observed it. So when sunlight fall on the water droplets suspended in the atmosphere, now you may think why it should be raining. So it is when the sunlight falls on the water droplet, after the rainfall, the rainbow is formed due to dispersion of light. So we talk little more about the rainbow now, and let's try to see some more details about the rainbow. Rainbow is visible only when the sun is at back of the observer watching other part of the sky. So I'll just try to show you to give you a little idea. It is like it is you who is standing here. It is like the sun is at back and there is a line meeting you and sun. I call this axis. So sun is at your back and it is you and you are observing and there is a line meeting you and sun. We can call it axis. There should be water droplets somewhere here at an angle say 41 degree from the axis, and from the sun the sunlight falls on these water droplets. I show these water droplets by blue color. So the sunlight falls on these water droplets, and then this sunlight, when it falls on these water droplet, it just refracts inside. I'm talking of violet color. So it refracts inside and then it reaches to you. Similarly, if you talk of some water droplets at an angle say 43 degree on this axis, the sunlight would fall on these water droplets and it is after final refraction, it is a red light which is reaching to you. So these water droplets which are hanging in atmosphere at an angle of 43 degree, from them the deviated color or the color after multiple refraction from water droplets that reaches to your eye is red prominently, and at an angle of 41 degree whatever water droplets are suspended, the color which reaches to you prominently after refraction is violet color, and in between all other colors. So that's how you get a primary rainbow at an angle of elevation 41 degree to 43 degree. And this primary rainbow has a color pattern violet to red, and it is going to be in the form of an arc because it is an angle of elevation, and that angle is with respect to the axis. Now you can understand, rainbow is visible only when sun is at back of observer watching other part of the sky. So you should be, as observer, you should be watching this side, other part of the sky, and sun should be at your back. It should be raining while the sun is also shining. So you need sunlight also in plenty and you need water droplets also. So it should be raining. And rainbow is formed as an arc of different colors, where center of the arc lies on the axis meeting sun and the observer. So where the center of this arc, so if this is going to be an arc, if the rainbow is in the form of an arc, I just show it like this. So where the arc center would lie, it is somewhere on the axis. So these are the important points about the rainbow. Now you can understand what are the necessary conditions for rainbow to take place. Sun should be at your back and you should be watching other part of the sky. In what angle? So it is 41 to 43 degree you get primary rainbow, and the color pattern is violet to red. And where is the center of the arc? It is on the axis. So this is about the basic idea about the rainbow, some important points. Some more important points about the rainbow. How exactly we want to differentiate, how exactly or what happened for different, angular width or for different color pattern in primary and secondary rainbow, and why secondary rainbow is fainter as compared to primary rainbow. The answer is, For primary rainbow, you can see over here, the refraction is taking place like this, and for secondary rainbow, the refraction is taking place like this. I will just show you. For primary rainbow, it is like this is water droplet. The white light falls, one refraction takes place, and light travels inside like this. Another refraction will take place. It will partially reflect, partially refract. There is no prism-like dispersion. It is like just refraction. So it partially reflect and partially refract. Again here, it partially refract and partially reflect. And again here it is normal. It partially reflect and partially refracts, bend away, and then it reaches to you. So in this primary rainbow, on every water droplet, there is 3 times partial reflection and partial refraction. So the light which reaches to you is after the 3 refractions. On the other hand, and there is 3 times loss before it finally is reaching towards you. But let's talk of in a secondary rainbow. In a secondary rainbow, if this is the water droplet, because this is upper part of the sky, 51 to 54 degree, the water droplet, it reaches here and then normal, and say it goes this way, again normal, partial reflection, it goes this way, again normal, and there is partial reflection, it goes here, and again normal, and then it finally goes out. So over here you have seen, as compared to primary rainbow, in the secondary rainbow the light that we finally receive is after 4 time losses. During partial refraction and partial refraction, that's why in secondary rainbow we see it is little dull as compared to primary rainbow. So you can see secondary rainbow, it is because of the 4 partial reflection and refraction of the light that reaches to you and from water droplet, and primary rainbow it is due to just 3 partial reflection and refraction of the light which is reaching to you. That's why primary rainbow is more clear as compared to secondary rainbow. But if the sunlight is quite bright and you are higher on the axis, maybe in the mountain area, you will see complete curve and you will see both the primary and secondary rainbow quite clearly. So that's how it is, and I hope you could understand it well. So you have now a good understanding of the concept of dispersion, the amount of scattering, and also a rainbow. We are in a good position to talk about numericals now.